Hello, welcome back to LeetCode Daily Live, where I do the LeetCode Daily question raw and uncut. So let's get started. So we have a minimum today. We have a medium today. Uh, I think it is something on array. So we have gotten off the trees and graphs, like segments. So what do we have today? So we have an array of integers, and it'll be 100,000. So we need n or n log n. Every value is 1 to 100. Return the number of subarrays with an odd sum. So since the answer can be very large, yeah, so that makes sense. Um, so let's see. Well, one way. Well, I think like the question is very easy to get, so you don't even really have to look at the examples. And also subarrays. Yeah, actually, let's make sure subarray has to be contiguous. Well, and yes, they are contiguous because we don't see any 2, 6 here. Oh, wait. Also, yeah, we don't see any, like, do we see any, subarray, wait, I think subarray is contiguous. Yeah, um, well, actually it doesn't say, right? Let me quickly search that up, but I'm pretty sure it is. So yeah, so it is contiguous, and yeah, it does tell you here that 1.5 doesn't exist. Yeah, okay. Sorry about that. But let's get to the drawing board. So it doesn't really matter whether you're like what numbers you're dealing with. What matters is the parity, right? So whether it is odd or even. So my first thought is like we can definitely convert like 111, like 135 to 111, or like 123. Like we'll convert that into 101. So like whenever it is odd, we turn it into 0. If it is even, if it is even, we turn it to 0. If it is odd, we turn it to 1. And like when we do the summation, like the summation mod 2 is going to be the same as like whatever it has in the original array. So like that's one way to make things a bit easier maybe, but we still have to think about like how we're going to use this array to actually to actually find the number of ways. So of course it will be too slow to generate all subarrays because of the large like bounds here. Like we need n or n log n way of doing it. So yeah, why don't we just think about it then? Um my intuition tells me that this should be dp. So so we want to start on the left, right? So and we want all the odd sums. So the base case would be just one element, right? So we have a 1 here. We can we can, the base case is like just one element. So our DP would be something like the number of ways from 1 to I. So that would be the DP, right? Yeah, so number from 1 to I. And then at the end, like DPN would be would be the whole array, right? So like that would be the entire array. Yeah. So that would be 1 to n, of course. Yeah. So if we have that set up, I think we can sorry, let me do something first. Yep. Just yeah. So if we do that, the base case would be like DP1 would just be 1 to 1. So whether the first number is odd or even, right? For the second number, so if we look at like 1, 2, 3 maybe, for the second number, it has to look back at how many ways like how many ways DP1 can form like odd sums, subarrays. So if we look back, actually, I know how to do this now. Uh, so it will be a 2D array, and actually let me draw it here, right? So like 1, 2, 3, like that would be the 1 to I part, and then here we want odd and even. So we want to find the number of ways we can form odd odd substrings with while using 1 as the last element, and then at the end we can just sum up the odd DP array up there, right? So in our case, so let's say for 1, 2, 3, well, what do we have? We have 1 here and 0, because the first element is odd, so it can form 1 odd subarray, and 0. If it is if the first number is even, then it will be the other way around. So for the next number, it is even, if we are doing 1, 2, 3. So let's not worry about this actually. So our array is just 1, 2, 3. So we're looking at the second element now. If it is even, well, the number of ways we can form with 2 as the last element, like any subarray with 2 as the last element, well, it will just be 1, right? Because we can form 1 odd, and we can't form any with even. So yeah, so we can, actually, I think we can form some with even, so it will be by itself, just 2 by itself, because we just want to end with 2, but there are more options at the front, right? So we should have 1 here, and then for 3 there will be well, we only have to look back 1 element back, because when we use 3, well, the first case is we only use it by itself, so it would be 1, 0 initially, but then we also can add, well, we can do the number of subarrays, even subarrays, and then we can add an odd number to form more odd arrays, right? So that will be 2, and then so on. So at the end, we just want to return the sum of this, and it is actually true. We have 1, and then we have 1, 2, we have 2, 3, and then we have 3, and that's all the subarrays we can form. So yeah, this is a DP problem, and let's get coding. So we want we want array length, just be length of array. Yeah, what else do we want? We want DP. So we want the DP array. Well, honestly, we can just set it as a list, and then we can just use tuples, right? We don't have to update anything after we have formed it. So yeah, tuple should suffice, or we can even use list of list, but let's just set it as an empty array for now. So the base case, actually, is the array going to be, okay, so the array will never be empty. That's good to know. So array, if array 0 mod 2, so that will be if it is even. Actually, maybe we can make a comment here. So number of odd, number of even. So we know that the first element is going to be odd, second is going to be even. So we want DP append 0, 1. Otherwise, we want DP append 1, 0. So that will be the base case. And then now for I in range, length of array. Honestly, we don't even need this. It might be just nicer to use length array directly. and it's not like it is slower anyways. So for I in range, so we want to like look at the next stuff. So again, we want to do that logic there. Oh, actually, yeah, maybe using a list is better because we do want to update it. We have like two things to check. So, well, it's not going to cost. It might cost a bit overhead, but it's fine. Yeah, so we want to initially set this. We'll just copy this, honestly. Yeah, we want to initially have this. We want to change this as well. Yeah, and then we want to do a bit more actually, right? So if we look back at this picture here, so if the number is even, we want to sum with the number of odds like on the previous one. If the number is odd, we want to sum with the number of evens. So we can actually just do it in here. Yeah, so how many evens can we form? Well, if the number is even, how many odds can we form? Well, that would be dp. We will look at the previous element, and we want to get the number of odd items it can form. And then here, do we need any more here actually? Yeah, we want to see the number of let me think about it actually. So yeah, we want to use like for DP we want to use the last element. So it's like do we have to deal with the even case then? Cuz like if the number is even, and like there could be, well, if the number is even, summing up with like the even subarrays that uses the previous element is not going to help because the sum is even, so we don't have to worry about that actually. Yeah, so actually we don't even need that. And then we just do dp. Well, it will be vice versa here. So if the number is odd, we want to get all the even, like the even subarrays that uses the previous character. And then at the end, we just want to return the sum of like of all the odd subarrays for elements in DP. Oh no, what did I do wrong? Let's print out the DP actually. Is it all set to 0? Huh. Oh, did I? That's quite strange, because if the 0 item is, oh yeah, I completely messed that up. That checks whether it is even. That's very strange. Well, now we get 1 0 1 0 1 0. Okay, what am I doing wrong? Right, so actually the number, yeah, I probably like missed some steps. Yeah, let's look at 135. Probably just missed something very stupid, but like originally we have what do we have? So we odd even. So we have 1 odd 0 even. 3, we want to, so it can definitely form with itself. But then you can also form evens by adding that, right? But you won't be able to have more odds. And then for 5, well, again, it is like odd even, but then it is, yeah, I think it's just how we deal with like the even number and stuff. So so let's look at this first, maybe. So if the number is odd, well, we can only form 1 plus the number of evens, right? Oh yeah, I think I just messed that up. And how many evens can we form? Well, it would just be the number of odds previously. Yeah, so I think I just missed that. Yeah. So if we have an even number, how many odds can we form? Well, we can form, well, it's just like the number of previous odd subarrays that you can form, but for even, we want to do 1 plus the number of evens you can form beforehand. Oh, and one more thing actually, we do want to mod all of these. Like here, we do want the modulo here. So int 9 plus 7. So we want to just mod everything. I need brackets actually. Yeah, this one doesn't need brackets. Okay, yeah, let's just mod everything. And then the sum, but again we want to mod yeah, well, honestly, like the mod here is not the nicest way. Like imagine all the elements are like very close to mod. Like you have to add all of them up. It would be like an astronomical number. But well, it should be still like under long. So long so int would be like 32-bit, long would be like 64. If all the numbers here are like 32 bits, we have 100,000 of them. It should still be fine. So whatever for here. Yeah, using list might be a bit slow because of that, but honestly, I want to check whether like using tuples are a lot faster. Yeah, because we don't actually need to update anything, which is quite nice. Yeah, let's see if it makes a big difference or not really. Make sure it runs first. I'm also printing the whole DP array. That makes a lot of sense. Why it is so slow? It's still quite slow, but maybe not using tuple, like yeah, maybe like initializing it with something might be quicker. I'm not sure, but yeah. Okay, well, but yeah, it's just a DP problem, pretty standard. And yeah, thanks for watching, and I'll see you tomorrow. Bye.